Okay, good morning, everyone. I'm very delighted to be here today. I'm going to share our research result, study of identifying attacks on industry Internet of Things using machine learning. I'm Zheng-Xun, and my advisor is Chia-Mei. Okay, this is our outline. First, I'll introduce our the Industry 4.0 and something related about ICS. The second part is our literature review. We will discuss about something like cyber attack on ICS and something literature review. The third part is our methodology. And the fourth part is our evaluation, and we'll discuss our future work in the final sector. The Industrial 4.0 revolution has dramatically transformed how manufacturing and other industrial companies operate, converging operation technology and information technology network together. And besides, in Industrial 4.0, emerging technology of 5G and IIoT makes industrial control system, which is ICS, become a major core of the critical infrastructure operation. And the ICS is a major, include SCADA and Industrial Automation Control System, which is IACS, Distributed Control System, DCS, and the Process Control System. As I mentioned at the previous slide, ICS play a significant role in industrial infrastructure, making sure each sensor works flawlessly without any error. But unfortunately, the sensor did not have any defense mechanism against cyber attacks. A lot of sensors are exposed to the public because of the prevalence of the 4G and 5G. This opened the door for attackers to compromise the organization. A lot of organizations and enterprise have implemented ICS for their business and manufacturing. However, according to some research, there are more and more cyber attacks targeting at ICS environment. Because the sensor is lacking security design, because they are very less powerful to handle those security mechanisms like antivirus and firewall. And here is some ICS attack in chronological order. The first is Starnet. It took place in 2010. It's the first known threat targeting at ICS. And in 2013, attacking Amy New York Dam from Iran were detected by United States Justice Department. And in 2017, a campaign group called APT33 conducted several cyber espionage on specific energy and aviation sectors in multiple countries. And in the 2018, WannaCry, this is a variant of the WannaCry. It infects ICS device and unfortunately infected TSMC in Taiwan, causing about 5.2 billion new Taiwan dollars and the manufacturing delay for high-tech chip. Yeah, so as you can see now, the attacker is going to target at a lot of ICS device. And here are the problems of the ICS. First, the ICS was designed to be deployed in intranet. However, because of the prevalence of 4G and 5G and the mobile network, lots of ICS devices are exposed by some. The second, it lacks security protection because the sensor have few computational resource, they may not afford extra application like antivirus and firewall. And without those security mechanisms, they are very easy to be exploited. And once they are exploited, the hacker can go into the intranet and steal some credential. And of course, a lot of organization or enterprise had noticed the problem, and they are applying traditional IDS and IPS. But however, traditional IDS are not efficient while detecting those attacks because lack of the sufficient attack signature for the various ICS protocol. So we study multiple research by different researchers, finding there are some research gaps, and there are two research gaps we are going to fill now. First, most of the current research focus on specific protocol, such as DMP3 and Modbus, which are common use protocol in ICS environment. But in real world, they may apply a lot of different protocol, not just the single specific one. So the research, there are few research targeting at this topic. So we are in this study, we detect with a lot of ICS protocol. And the second is some research analyze the network packet one by one, not the entire traffic flow of the transaction. Because it's important to identify the traffic flow. Because if you only focus on packet, you may not find some relationship of some relationship of some packet between packets. Yeah. To solve the problem, our study proposed a classification method to detect anomalies in heterogeneous network environment with two-step phase. And this is our proposed methodology. First, you can see we have two steps. First, this is our data. So they are going to under preprocess first. Then the first step, we are going to do some protocol categorization. So the protocol will be, the protocol will be split. And the second phase, we are going to do some feature encoding and the detection model. Okay. In preprocessing stage, we are finding the traffic flow from the packet. We will analyze the packet, network packet, and filter out flow by flow. And second, we'll remove some invalid and missing data because some packets are in the format of some packets are corrupted. So those packets are also removed. The third, we are going to standardize our numerical data. And because our data set is imbalanced, so we are also, the data set is undergo some upsampling. Can you see our screen, because there's some blocking here?
Yeah, we can see it.
Okay, thank you. The first step is the protocol categorization. Industrial IoT may communicate amongst each other in heterogeneous network protocol. And the proposed system identify protocol by analyzing the packet header. So given the knowledge of the protocol format and the value range of each field in the header, this module of protocol categorization can identify the protocol by examining the header. The second phase is feature encoding. And this phase transforms categorical data to continuous variable, such as protocol type. And the data packet is converted to hexamer format, and also with its Shannon entropy value to be another feature. And the TCP/IP features such as source IP, destination IP, ports, and the packet size are also included. And the last is ICS features such as the transaction ID of the ICS device, protocol ID, and their function code. And there is our detection models. ICS process perform periodical tasks. Therefore, the communication contents amongst the IIoT device are stable and periodical. The LSTM is one of the neural network that is suitable for learning time series and the periodical patterns, according to our literature review. And the loss function we use in the LSTM model is binary cross entropy, where the cross entropy loss increase as the predicted probability of the diverge from the actual label, and penalize the misclassification greatly to build a good detection model. Most model learning optimizers are based on the stochastic gradient descent technique, and we use RMS-Pro because instead of treating the learning rate as a hyperparameter, RMS-Pro is suitable for learning a model from a big or redundant data set. Our data set is contain a lot of packets and packet traffic flow, and from heterogeneous network. So it's very big and contains some redundant data. So RMS-Pro is suitable for our model optimization. And here is our evaluation. This study evaluated the proposed solution with the data set from multiple sources and divide them into the training test and the training set and data set with the ratio of 8 of 2. Those data sets were downloaded from net. The data set we use are downloaded from internet, from GitHub. And the data were collected from different environments, such as power system, gas pipeline, and the water storage tank. And there's a duplicate. Yes. So because I mentioned before, many of the research only focus one scenario, and by applying those data sets, we can simulate that the network contains a lot of ICS device, different ICS device. And here is our result. The accuracy we can gain is 97.06, and the precision is 94.85, and the recall is 97.42. And the F1 score is the combination of the precision and the recall. That is the harmonic means of the precision to compare the two models in this study. The F1 score is the range of the F1 score is 0 to 1, and the bigger it means the model is the better. The F1 score we gain is 0.9612, So it shows our detection model is sufficient and efficient for multiple scenario environment. So this is our discussion. We propose a machine learning-based classification model to identify anomalies on heterogeneous IIoT network environment. And we also implement protocol categorization, which can reduce the training time as well as improve the detection efficiency on the heterogeneous network environment. So our future work this is our future work. First, some of the enterprise is going to combine their IT and the OT network together, which is they can control their OT system with their IT technology. So by combining IT and OT, the structure of the network is more complicated. So the defense in depth is recommended by implementing layer of the defense of merchandise. And this study can be extended to implement defense in depth by applying IT network protection. So this is our future work. Okay, let me conclude our contribution of this study. This study developed an efficient and sufficient detection model that is able to deal with the different types of the popular protocol in ICS, such as DMP3 and Modbus protocol. And the second, we are analyzing the packet by traffic flow efficiently and effectively. And the third, because the data set we use contain a lot of different scenarios, so this detection model can deal with sundry ICS environment as well. So this is our contribution. Thank you for listening. Any question?